one of the benefits of automation as well, and when I was talking about part consistency and in some of the assembly processes, being able to take some of the quality control and bring that in process. This system here is literally a robot picking up a part, setting it into a small CMM and getting measurements on it. And so what's happening is you'll see two locations where the part can set. This actually is getting smashed in between a process. So a robot's actually loading the one station and then another robot's unloading the other station, right? So this robot's job is literally to pick this part up and put it in a gauge and measure it. Some of the cool things that happen with a system like this, especially in machine tending. So you imagine you machine 700 parts and then you gauge a couple of them and you find out, oh crap, 200 of those parts, I had a bad tool in there, they're all scrap, right? This allows you to darn near, allows you to measure every single one, but now say you did find a scrap one, you can shut that machine and that process down immediately, right? So you might end up with 2 bad parts or however many are in queue instead of 200 at the end of the day. So this is a big thing with the costs of some of this inspection equipment, CMMs and stuff coming down. That's actually allowing you to 100% QC check all machined parts and be able to really have control over scrap, right? And so that instead of scrapping a large batch or finding out that half the shift that day we were doing something wrong in that machine, it allows you to kind of narrow that down to every single part and really controlling those costs. We've had some processes that I've seen in the past in machining that was some really high-end machining, very delicate, that their scrap rate paid for an inline QCing of it. If they could eliminate, 80% of their scrap by doing this, it more than paid for a robot to be double checking the part measurements right in process. So that's a very cool concept. It brings you closer to that lean manufacturing or single part flow. Next video here is an example of something I spoke about earlier, is plasma cutting with a robot, right? So feeding a tube in and having the robot programmed to perform the cutting over and over and over again. Very cool, very easy to program, but again, the biggest thing is just going to be the consistency with this. You're going to get the same cut every time, even better cut than relying on an operator to do this by hand or doing it some other way. So a lot of different possibilities with this too, with square tubing, round tubes, I-beams, anything steel that you can get in there, I guess, or metal you can get in there to start cutting. You can put a plasma cutter very easily on the end of a robot and allow it to do the cutting. The cool thing is nowadays, with everything being shifting towards the 3D CAD world, right? There's still a lot of drawings out there that are 2D. There's a lot of people moving into the 3D world. There's a lot of offline programming software, right? So historically, you need to teach the robot to run this path that you're seeing this robot run. There's softwares out there now that you can load all of this in there virtually, given a 3D model of everything. It has exactly how the robot runs and how it does that. You calibrate the real system to the offline system, and from that point on, you could load in the 3D CAD of that part it just cut and tell it, I want you to program this part. And so the software will program it for you. You bring that file out to the robot, load it in, do a couple test cuts, and you're cutting it. And so instead of shutting production down to stand there with the robot and teach new parts or add parts to a system, you're able to do that from a desk while the robot's running production, right? If the robot's not running production, you're not making any money on it. So to be able to program something offline and have the robot shut down for 10 minutes instead of a half a day, that's huge. So here's an example of an assembly process. So this process is taking an O-ring and assembling it onto a part here. So it's dispensing some rings out. A gantry style robot's picking it up, putting it down. This one also shows an example of vision on the end of a robot, right? That's another thing, you know, another layer. It's like, geez, if I historically without vision on a robot, if you don't set that part in the exact same spot for it to pick it up, it's only going to the spot you told it, right? So now the advances in vision, whether it be 2D vision, 3D vision, allow you to be a little less rigid in areas. The robot find the part. Maybe there's clocking needed on the part, right? So there's a notch on one side or a keyway that goes through a part like this, for example, that when you're assembling it needs to be set right to that keyway or is relative to the keyway. The robot can find that, right? We don't have to find a fancy way of making sure that that part is rotated properly each time. So this is a very cool example of that, doing some assembly work that we talked about earlier. This is just a fun one to watch, but what these are is ceiling tiles, right? So you imagine the ceiling tiles you got in an office or whatever, but this is a cool example of a robot doing cutting in process. The coolest thing about this is the part never stops moving. So there's options now with what's called line tracking, and you can put a robotic encoder, which gives feedback of speed and position to the robot. It's the same thing they use on their motors on the robot itself, but you can mount that to a conveyor or to a press brake or to a myriad of different things, and the robot knows the exact speed that now this part is running and can do its process while the part is moving. And so this robot, and it's tough to tell in this video, but it makes a perfectly square cut to this even while the part's moving. And so the cool thing is you don't have to stop, make a square cut, start again, stop. This thing just does it really on the fly. So there's a lot of things out there now that allow increased throughput in robot systems because you can keep the part moving. For example, that first assembly system I showed in the what can be automated section of my presentation, those parts were actually all being placed onto fixtures, and there's 4 fixtures on 13 different rungs on a conveyor, and it never stopped moving. And those robots just kept assembling the pieces as they were moving down. They got crimped together and dropped in a basket, but they never stopped. They were always moving. So some really cool options there as well. Got one more video for you guys here. These videos get pretty limited out of our automation group because there's a lot you can show, or some you can show, and a lot that customers ask you not to. So this one here is actually depalletizing. So we talked a little bit about palletizing in the presentation where we're stacking boxes. This is actually taking a pallet that's come into a customer with a whole bunch of wood stacked on top of it, and it's depalletizing the wood and putting it into a cartridge that is then feeding a machine that builds pallets, right? So those are slats for a pallet. And so what this allows you to do is feed an assembly machine with a robot without having to have somebody stand there and take wood planks off of a large pallet all day long. So that is what I have for the virtual tour. Like they mentioned, I'll